Hi, so in this video I'm going to introduce you to the polar coordinate system. So we have a Cartesian coordinates here, x and y, and we're going to look at how we can write these general coordinates in polar form. So on a polar grid we begin with what's called the pole, and this is similar to the origin on the Cartesian grid. And from the pole we have the initial line. And to show this, we often write theta equals 0. I'll explain more about theta in a moment. And it's often easier to show these dashed lines to visualize the 4 coordinates as we rotate around 2 pi radians from the initial line. So to get to x and y on our polar grid, we can plot this about here. We need to travel from the pole to the point, and this is the radius. But to make this point fixed, we rotate anti-clockwise from the initial line by angle theta. So theta is always positive when it's anti-clockwise from the initial line. So if the radius was fixed and we could vary theta, then the radius would form a circle around the pole. So the general coordinates then of this point would be r, the radius from the pole, and the angle theta, which is anti-clockwise from the initial line. So these are the general coordinates for the polar grid. Okay, so now we're going to look at converting Cartesian coordinates to polar form. So we have the Cartesian coordinates of 2 root 3 and 2. So this gives us our x value of 2 root 3 and our y value of 2. And you can see that we can create from our x and y a right angle triangle, when this is the hypotenuse, and here is our right angle. So to convert these to polar form, I'm going to sketch a polar grid. So we have our pole and our initial line, where theta equals 0. So to work out the radius, we can apply a Pythagoras' theorem to this right angle triangle. So the radius will be the square root of 2 root 3 squared plus 2 squared. This gives us the radius of 12 plus the 4, so square root of 16, which is 4. So we know that our radius is 4, now we need to work out theta. But theta travels anti-clockwise from this initial line. So what we need to find out is this angle here. Well, now we can use trigonometry, where the tan of the angle theta will be the opposite 2 over the adjacent 2 root 3. So theta will be the arctan of 1 over root 3. Theta is equal to pi over 6. So now we have the radius and theta. Our polar coordinates will be 4 and pi over 6. Okay? Let's try converting polar form to Cartesian form. Okay, so in this example, we've been given the polar coordinates of root 2 and pi over 4. So this will give us the radius of root 2 and the angle from the initial line going in the anti-clockwise direction as pi over 4. So now I'm going to show the x value and the y value. And you can see that we've now created a right angle triangle. So to work out the x value, we can use trigonometry. Where we want to find the adjacent side, we have the hypotenuse and the angle. So the cos of pi over 4 will be the adjacent x over root 2, the hypotenuse. So therefore, x will equal root 2 cos pi over 4, which is equal to 1. And the y value, well, this time we'll use sine. So the y value will be root 2 sine of pi over 4, which is also 1. So the Cartesian coordinates will be 1 and 1. Okay? Let's try one more example. Okay, so in this example, we've been given the polar coordinates 5 and an angle of 2 pi over 3. So we're going to work out the Cartesian coordinates. But we need to show that this angle is 2 pi over 3 from the initial line. And to create this as part of a right angle triangle, I'm going to consider this triangle, which means we need to work out this angle. But if this is pi, and this is 2 pi over 3, this angle will be pi over 3. And the radius we're told is 5. So to find this x and y value, so x will be equal to 5 cos of pi over 3, which gives us 2.5 or 5 over 2. Our y coordinate will be 5 sine of pi over 3, which is 5 root 3 over 2. So in Cartesian form, the coordinates will be 5 over 2 and 5 root 3 over 2. Okay? So next we're going to look at converting between polar and Cartesian equations. Okay, so for the next part of our video, we're going to look at converting between polar equations to an equivalent Cartesian equation. So in example A, we've been given the polar equation that r equals 3, and this is represented by the circle on the polar grid here. So to convert this to Cartesian form, we're going to use this equation here, r squared equals x squared plus y squared. But to do this, we need to square both sides of r equals 3. So if we square r, we get r squared, and if we square 3, we get 9. And now we know that r squared is equal to x squared plus y squared. So x squared plus y squared will equal 9. And this is the equivalent Cartesian equation for this polar equation. Okay, so for example B, we've been told that r is equal to 4 cosec theta, and it is represented by a horizontal line on our polar grid. So you'd expect the Cartesian equation to be equivalent to y is equal to something. So we know we can write cosec theta as 1 over sine theta. So r will be equal to 4 over sine theta. So we get r sine theta is equal to 4, and we're told that r sine theta is equal to y. So we can replace this with y, so therefore y is equal to 4, which is what we thought it would look like. Okay? Let's try one more example. Okay, so finally, we've been asked to show that r squared equals sec 2 theta is equivalent to the Cartesian form of x squared minus y squared equals 1. So the first thing we're going to do is to write this as 1 over cos 2 theta. So r squared is equal to 1 over cos 2 theta. But when we deal with polar equations, we need theta, not 2 theta. So we're going to use the double angle formula, that cos 2 theta is equal to cos squared theta minus sine squared theta. And I'm also going to move this to the left-hand side. So we get r squared, lots of cos squared theta, minus sine squared theta is equal to 1, and then we'll expand these brackets out. So we get r squared cos squared theta, minus r squared sine squared theta is equal to 1. And because we're told that x equals r cos theta, this means that x squared will be the same as r squared cos squared. And similarly, this will be equal to y squared is equal to 1. And this is exactly what we were trying to show. Okay? Well, thank you very much for watching. I hope you found that useful. You can download a full lesson and worksheet from my website, mrmathematics.com. There's a link in the description below. Thanks again, and take care.